New York-sized ice shelf collapses in East Antarctica after heat surge. For the first time since satellites began observing Antarctica nearly half a century ago, ice sheets have collapsed on the eastern half of the continent, scientists say. The collapse of the 450 square mile conger ice sheet in the part of the continent called Wilkes Land occurred in mid-March. It was first spotted by scientists at the Australian Bureau of Meteorology and appeared in a satellite image taken on March 17, according to the National Ice Center in the United States. An ice shelf is a floating tongue of ice at the tip of the glacier that serves as the outlet for the large continental ice sheet of Antarctica. Pressure causes cracks in the floating ice, and melting water and other factors can cause the cracks to erode and rise to the point where the sheet collapses rapidly. According to the National Ice Center, the largest fragment of the conger shelf after it collapsed was an iceberg called C-38, measuring about 200 square miles. The loss of the ice sheet can cause the glaciers behind it to move faster, which can result in faster ice sheet loss and thus greater sea level rise. Ice sheet loss is a major problem in West Antarctica, where global warming is having a bigger impact than warming in the east. Some of West Antarctica's very large glaciers are already flowing faster, and if the ice sheet collapses completely, sea levels could rise as much as 10 feet over the centuries. But the two glaciers behind the conger sheet are small, and even acceleration will have a minimal effect on sea level, on the order of an inch part or in a century or two, said Ted Scambos, senior researcher at the university's Center for Geosciences. An observation, Colorado Boulder. While some ice sheets collapsed in West Antarctica, or most notably the much larger Lawson B in 2002, the conger collapse in East Antarctica has collapsed since the era of satellite imagery in 1979, said Catherine Walker, a glaciologist at Woods Hole Oceanographic in Massachusetts. Dr. Walker, who has been monitoring the ice sheet for several months, said he had been retreating for several years. In the beginning, it was an unhealthy ice sheet, he said, but it appears to have stabilized between the mainland and the small island. He said, while the crash didn't come as a complete surprise, it did happen earlier than expected. You and Dr. Scambos agree that recent times may have played a role in this part of Antarctica. In mid-March, an atmospheric flux, a water vapor rich air current, flows northward from the ocean into East Antarctica. This has caused record heat in some places, with temperatures up to 70 degrees Fahrenheit, above normal for this time of year. Heat can cause the surface of the conger ice sheet to melt more, which helps abrade the cracks and accelerate them. But Dr. Scambos said windy conditions stemming from atmospheric flows, combined with record low sea ice around Antarctica, were likely to play a bigger role this season. Sea ice acts as a buffer and dampens waves rolling toward the coast of the Southern Ocean. With less ice and more wind stirring the oceans, the floating shelves are more flexible than usual. Flexing likely weakens the stronger sections of ice that hold the layers together, said Dr. Scambo. Warm swings may not contribute much, he said, but wind and warm temperature events in the air and sea certainly don't contribute to ice sheet stability. East Antarctica is considered the more stable region of Antarctica, with less warming and even increased ice in some areas. The collapse of the conger ice sheet didn't really change that view, said Dr. Walker. We are not seeing any signs that this is going to happen anytime soon across East Antarctica, he said. Dr. Scambos, who studies glaciers and the more vulnerable glaciers in West Antarctica, said it would be interesting to see what happens to the glaciers behind conger. Every time one of these happens, He says it tells us a little bit more about how much Antarctica will react when the bigger event happens. Thanks.